In this video, we will graph linear inequalities by testing points for the solution. You are going to need graph paper for this set of notes. So a linear inequality looks a lot like an equation, but instead of an equal sign, it's going to use one of the inequality symbols, like less than or greater than, or greater than or equal to, or less than or equal to. The solution to an inequality is just like a solution for an equation. It's any point that makes that inequality true. So we have some points down here, and we want to determine if these ordered pairs are solutions to the inequality 2x minus 3y is less than 15. So the way we do that is we see if those points make the statement true. So by taking the point 2, 5 and substituting its values into the inequality. We've got 2 times the x value of 2 minus 3 times the y value of 5 is less than 15. By simplifying the left side, we get 4 minus 15, which is a negative 11. And negative 11 is less than 15, which means that the point 2,5 makes that true. So 2,5 is a solution. I want you guys to stop the video here and go ahead and test the next 4 points to see whether or not they make the inequality true. We're actually going to use this information in what we do next. Now that you've looked at those ordered pairs and determined which points are ordered pairs, let's compare that to what that looks like on the graph. So we have our inequality 2x minus 3y is less than 15, and we have our set of coordinates. Notice that A and D were the only solutions here, 2, 5, and 0, 0. Notice where they are on our graph. Points B, C, and E ended up not making the inequality true. Notice where they are on the graph. So we have this shaded region that represents our solutions. That's the answer to this question here. What does the shaded part represent? The shaded part represents any possible point that could make that equation true. We could test another point, like negative 2, positive 2, and it would make the inequality true. But if we tested a point in the unshaded part, like 4, negative 6, that point would not make the inequality true. So therefore that point would not be a solution. So the shaded part represents all possible solutions to the inequality. So we compared the points from the last page with the points on this page. I want you guys to answer the questions. Which points were the solution? Where did we find those points on this graph? And then I want you to think about the answer to this question. Why is the line a dashed line instead of a solid line? So notice that it's dashed. I want you to think about the solution on E. Was point E at 6, negative 1 a solution? Did it make the inequality true? Well, no, you got 15 is less than 15. And 15 is equal to 15, not less than. So the point on the line was not a solution. That's why our line is dashed, because the points on the line here are not going to be solutions. All right, let's take a look at some examples. I want you to have these examples individually on your notes. All right, so the first example, y is greater than 2x minus 1. We're going to graph this line just like we would an equation, but we have to shade and consider whether it's a dashed line or a dotted line. So negative 1 is our y-intercept. Our slope is still positive 2. So negative 1 is our y-intercept, up 2 over 1, up 2 over 1, so on and so forth. And we have our line graphed. Now let's test a point on either side. So we're going to test the point 0, 0, because 0, 0 is not on this line, so it will tell us where we need to shade. Okay, so 0 is greater than 2 times 0 minus 1, and that becomes 0 is greater than negative 1. So is that true? Yes, 0 is greater than negative 1. So we know 0, 0 is a solution. So we have to shade the side of the line that contains that point. So we shade where 0, 0 is. Notice that the line here is dashed. If we were to try the point 0, negative 1, we would get an untrue statement or a false statement. So the line is dashed because the points on the line are not solutions. Okay, let's look at y is less than negative 1/2 x plus 1. We plot the line just like we would an equation. So our y-intercept is positive 1, and our slope is a negative 1/2. Now we're going to test the point 0, 0 again. That's the easiest point to test. So 0 is less than negative 1/2 times 0 plus 1. So 0 is less than 1. That's true. 0 is less than 1. And so we would graph below, which contains our 0, 0 point. Notice again that the line is dashed because the points on that line will not be solutions. Okay, let's take a look at y is greater than or equal to negative x plus 2. Plot the line like we would any equation, but this time we have the inequality. So test 0, 0 here. 0 is greater than or equal to negative 0 plus 2, which is just 0 is greater than or equal to 2. Well, is 0 greater than or equal to 2? No, that's a false statement. So we cannot shade the side that contains 0, 0. We would have to shade the other side. And so now we've shaded above the line. Now notice here that the line is solid. The line is solid here because if we plugged in a point on our line, we would get a true statement because we have that equal to. So for example, if we plugged in 0, 2, we would get that 0 is greater than or equal to 0. Well, that's a true statement. 0 is equal to 0. So that's when we change to that solid line, when we have that equal to. Y is less than or equal to 2/3 x minus 3. Graph that line like we would an equation. Notice again it is solid because we have that equal to. Points on this line will make a solution. All right, so let's try 0, 0. Is 0 less than or equal to negative 3? And the answer is no. So we would shade on the side that does not contain the point that we tested because we got a false statement. All right, I want you to notice some patterns here. Notice that with greater than and less than, both of these lines are dashed. So when you have greater than or less than, you're going to have a dashed line. When you have greater than or equal to or less than or equal to, you're going to have a solid line. When you have greater than or equal to, notice when we graph that line, we've shaded above the line. So when we have greater than or equal to, we're shading above. When we have less than and less than or equal to, notice we're shading below the y-intercept. So we're shading below when we have less than or equal to. I also want you to notice that each of the equations are already in that slope-intercept form where y is by itself. That's very important here. All right, now we're ready for you to practice on your own. Okay, here's an example that I want you to do on your own. Y is greater than 1/3 x minus 5. Graph the line and shade its solution. Y is less than or equal to negative 2x minus 1. Do this one on your own. With this one, notice that it is not in that slope-intercept form, so we have to put it in that form first. So we have to subtract the 5x from both sides and have negative 2y is greater than negative 5x plus 12. But then we have to divide by negative 2. Remember, when we divide by a negative, what happens to our inequality? When we divide by a negative, that inequality sign flips. So instead of having greater than, we now have less than. So that when we graph this line, we have our -6 as our y-intercept. It is a dashed line, and we have our 5/2 as our slope. So this is our line graphed. Now where do we shade? Test your point 0, 0. If we were to plug in 0 and 0, we would get 0 is less than -6. Is that true? Is 0 less than -6? No. So we would shade on the other side of the line. Once again, notice we have less than. So less than is a dashed line and shade below, which is what we ended up with, a dashed line where we shaded below. All right, a few more examples to do on your own. X minus 4y is less than 8. 3x plus 2y is less than 0. Y is less than or equal to -4. X is greater than 7.